This is notes for 1.2 for 6th grade. We are going to talk about powers. Power is the product of repeated factors. So b to the x power, the whole thing is called a power. The base is the repeated factor. So b here would be the base. So with the power, the whole thing is called a power. This number here is called the base, and then the last number, the little number up on top, is called the exponent. And the exponent is the number of times the base is used as a factor. So the power is the whole thing. The base, it would be the bigger fonted number, and then the exponent is the little fonted number, or the number up above. And it's very important to learn how to write a power correctly, because you do not want your power to look like a number. You have to be precise. So in words, if we are talking about a power and we want to explain it in words, 3 as a base, 2 as an exponent, we can call this 3 squared, or 3 to the 2nd power. Now the reason why it is called squared is 3 to the 2nd power, or 3 squared, is 3 times 3. When we take two numbers, especially in area, or when we talk about area, a square, let's say it's 3 by 3, if we take 3 times 3, we get a square. It's kind of like following in the terms of area. So we can call this 3 squared, or 3 to the 2nd power. The next one, we can call this 3 cubed, or 3 to the 3rd power. So anytime you see an exponent of 2 or an exponent of 3, they have special names, squared and cubed. Otherwise, you can just call them how you see it, 3 to the 2nd power, 3 to the 3rd power. The last one does not have a special name. It's 3 to the 4th power. And then if we have any exponent bigger than 4, it's just the 5th power, the 6th power, the 7th power, and so on and so forth. You can think of these as area and volume, squared and cubed. Okay, write the product as a power. So we need to figure out what is our base and what is our exponent. So let's look at A. The number that's being repeated is a 4. So 4 is our base. How many times does 4 repeat? Well, it repeats 1, 2, 3, 4, 5. So 5 is up there. Now, make sure you put that at, make sure you superscript it. Okay, meaning write it little and above, a little above the 4. I do not want to see this. That's 45. Okay, be very, very precise in how you write your math. B, again, this is multiplication, these times. I don't like that necessarily. Anytime you write a multiplication problem, make sure you use the dot. So the number that's being repeated is the 12. How many times does 12 repeat? Well, it repeats 1, 2, 3. 3 times. So we put a 3, write a 3 really small and above the 12. On C, 6 is being repeated, so that is our base. And then it's repeated 3 times. And then the last one, 100 is our base, and it's being repeated twice. So the number of times your number is repeated, you put that number smaller and upstairs, or whatever you want to call that. And then the number that's being repeated, that's your bigger fonted number. 4, 6, 12, 100. Okay, you will have some problems like this on your assignment. Let's turn to the back. Find the value of each power. So what we're going to do is rewrite this opposite of what we just did. So 7 squared, that's the same thing as saying 7 times 7. Now it says find the value of each power. So we need to go ahead and solve for this. So 7 times 7 is 49. The next one, we have 5 times 5 times 5. In any time, or any work I show on the notes is what I want you to do on your assignment. So I don't want you to skip anything, otherwise you won't get full credit. Okay, so 5 to the 3rd power, or 5 cubed, is the same as 5 times 5 times 5. So 5 times 5 is 25. 25 times 5, think of quarters. How much money do you have if you have 5 quarters? Well, you're going to have $1.25. Or if you want to do some scratch work, and all great mathematicians do scratch work, 5 times 5 is 25. 5 times 2 is 10. Add the 2, and that gives us 12, so 125. That almost looks like a 6. There we go. So 5 to the 3rd power is 125. 6 to the 3rd power, that's 6 times 6 times 6. Well, we should know 6 times 6 is 36. We need to take 36 times 6. 6 times 6 is 36. 6 times 3 is 18, 19, 20, 21. So our answer is 216. Now later on, when you get into 8th grade, I know that's 2 years from now, when you get into 8th grade, you will actually memorize these basic squares and cubes. So when you see 7 squared, you should automatically know that's 49. If you have 5 to the 3rd, you should know that's 125. Which comes to the perfect square. Perfect squares. So perfect square would be this 49. Perfect square is the square of a whole number So pick any whole number. Let's go with 3. And we're going to square that. So that means 3 squared means 3 times 3. 3 times 3 is 9. 9 is the perfect square. And the reason why it is a perfect square, if you think of a square in general, a square has the same sides. All sides are equal. So if we put a 3 on the height and 3 on the width, 3 times 3 is 9. So the area is a perfect square. A 3 by 3 is a perfect square. Okay, the next part. Determine whether each number is a perfect square. Okay, so we need to figure out what number times itself will give us these numbers, if there is any. So for 64, let's think here. 64. Well, we know 7 squared is 7 times 7, which is 49. Let's see what 8 is. 8 squared is 8 times 8. 8 times 8 is 64. So yes, it is. Okay, and I don't want you to just put yes or no on these. I want you to have evidence. It's just like being an investigator. You cannot tell me just yes or no that the murderer did it or not, or the person you think it is did it or not. You have to back it up with evidence. So here's my evidence. Okay, for 20. Let's see here, 20. Well, let's say 4 squared, that's 4 times 4. That's 16. Oh, that's not 20 though. So let's think of 5 squared. 5 squared is 5 times 5, which is 25. 20 is in between 16 and 25. 16 is perfect and 25 is perfect. 20 is not. So we will say no. And this is our evidence. Make sure you do not forget your evidence. If you just put yes or no, I'm going to take off all your points. For 25, well, we just had our evidence up here, so let's rewrite it down here for this problem. Okay, sometimes in math, some of your evidence that you found in one problem will be used or could be used in another problem. So this would be a yes, and there's my evidence. And how about 99? Let's talk about 9 squared. 9 times 9 is 81. Well, that's not 99. So 9, so let's think of another whole number. Let's go 10. 10 times 10 is 100. Well, 100 is not 99. 99 is between these two, so this would be no. Okay, so with this, just pick a whole number, square it, and figure out if those numbers will work, or if you can come up with that number. And you might have more evidence than me, and that's okay. I want you to keep your evidence on your paper, so I know how much thinking you did. Okay, the last part. You complete 3 centimeters of necklace in 1 hour. Each hour after the first, you triple the length. Write an expression using exponents for the length of 3 hours, then find the length. Okay, so that was a lot. You complete 3 centimeters in 1 hour. Okay, so an hour passed, we have 3 centimeters. Another centimeter, or another hour, we completed 3 more centimeters. Each hour after the first, you triple the length. Write an expression using exponents for the length after 3 hours. Then find the length. So it looks like we will start out with 3 centimeters. And then for each hour, so we spent 3 hours on this thing. Okay, so 3 hours. So really what we could do is, here's the first hour, that's 3. Okay, you completed 3 centimeters of necklace in 1 hour. So that's our first hour. Each hour after the first, so that's our first hour. Our second hour, we tripled the length. So that means we have to take it times 3. Write an expression using exponents for the length of 3 hours. Well, that's only the second hour. So we triple it again, and that's 3 hours. So this means that this is 3 to the 3rd power. So it says write an expression using exponents for the length after 3 hours. So write an expression. That's a command. That's a statement. So we have it already. Find the length. So 3 times 3 is 9, times 3 is 27. So we completed 27 centimeters after 3 hours. Okay, so I hope that makes sense. This first hour, we already completed 3 centimeters. And each hour after that, we triple the length. So if we have 3 centimeters completed the first hour, and we triple the length, so that means that we have 9 centimeters. And then after our third hour, we should have tripled 9 centimeters to 27 centimeters. So this will conclude 1.2